We will now introduce a new class of functions to our library of functions in this course called exponential functions. The general form of an exponential function is f of x equals c times a to the x power. The base of that exponent has to be greater than 0, a has to be greater than 0, and a cannot equal 1. And a, we call this the growth factor of the function, and I'll show you why here shortly. And c is the initial value of the function. And that's because if I substitute a 0 in for x, if I find f of 0, I have c times a to the 0 power. Well, anything to the 0 power is 1, so this is just going to give us c. So that's why we say that c is the initial value of the function when that x value is 0. It's important to distinguish exponential functions from powers of x, or power functions. So we want to distinguish by the variable is in the exponent. So any function that has an exponent in it isn't necessarily exponential, but if the variable appears in the exponent, it is exponential. And then the base is the constant. So look at some examples. So here's an example of an exponential function, y equals 1/3 to the x power. So we can see that the exponent contains the variable and the base is a constant. Another example would be, excuse me, y equals 5 times 2 to the x power. So again, here the base of the exponent is 2, and the exponent is that variable x. Another example would be y equals negative 6 x to the x minus 2 power. Okay, some examples not to be confused with exponential functions. Y equals x to the 1/3. So here, although it contains an exponent, the variable is not in the exponent, so this is not exponential. And then a power function like y equals 5x squared, again that contains an exponent, but the variable is not in the exponent, so it's not an exponential function. So you want to make a note here. Don't confuse with power functions, which we studied in the last chapter, like x squared, x cubed, etc. Okay, so let's explore these exponential functions a little bit on the calculator. So we're going to graph 2 to the x power, so I'll use the arrow here of the caret to raise to the x power, and then I'm going to graph 1/3 to the x power, and then I want to enclose the base 1/3 in parentheses and raise it to the x power. Okay, so we're going to look at the table of these functions first. Okay, so we can see y1 here, this is the 2 to the x function. So as we move from up one x value, so I go from -1 to 0, 0 to 1, 1 to 2. If you notice, we're doubling. So I have a 0.5 here, a half. I double it and get 1. I double 1 and get 2. I double 2 and get 4, etc. So this is our 2 to the x function. So the growth factor of this function, the base is 2. That's the growth factor because every time x increases 1, the y value is growing by a factor of 2. Now if we look at y2, this was our 1/3 to the x function, and here as we go up 1 in the x value, 3 divided by 3 is 1, or 3 times 1/3 is 1. 1 divided by 3 is 1/3, or 1 times 1/3 is 1/3. So here, every time we move up one x value, we're growing, and in this case we're actually, it's a negative growth, by a factor of 1/3. So that growth factor, the base of the function, that's how much the y value is going to grow, the factor by which it's going to grow for every increase in x. So if we want to make just a little note of this in our notes here. So we graphed y1 equal to 2 to the x, y2 equal to 1/3 to the x, and then we just made a little table. This might be nice to refer back to. So you've got your x value, your y1, and your y2. So just a few example values here. I had -1, 0, and 1. So for y1, the 2 to the x, we had a half. And then for 0, we had a 1. So we're multiplying by a half each time. Or sorry, we're multiplying by double each time, by 2 each time. And then 1 times 2 is 2. And then for y2, when x is -1, we had a 3. And then we multiply that by a third, and we get 1. And we multiply that by a third, and get a third. So if you just want to make a little note here, for each of these, we're multiplying by 2. And then for y2, between each two consecutive values, we're multiplying by a third. That's the definition of an exponential function.